In this next section, we will examine how easily these templates can be generated and the virtually unlimited amount of data that they can capture. In other words, how are the medical problems developed? What type of content do they contain? In this section, we return to the main page of the medical editor. We're going to explore the content of a simple choices type problem and look at how it can be modified and expanded. We have already loaded ABD RLQ exam choices into the editor. We saw what the screen display looked like in the previous section when the user chose right lower quadrant pane from the graphic and entered a positive SOAS sign. Now let's examine the tab labeled Instructions. When we click on that, we see that each template has a series of instructions. Each instruction contains all of the information associated with one choice. If we look at the left-hand column, it is labeled a question, as we can see at the bottom. This is what the user will see when the template is displayed. So each instruction may have a question, and each question, as shown in the right-hand column, may have a text return, if that particular question is chosen. Some questions do not have an associated. In this case, it's because they are headers or titles. For example, note that the header guarding has no associated text return. If the user chooses local guarding, the text will display there's local guarding in the RLQ. Text returned is but one of many different elements that can be displayed, as we can see that is from the list that is available in the lower right-hand corner. For example, if we look at the field assignment, which determines where in the record the text should be displayed, we see that all of these outputs are assigned to the abdominal EX, which will place the text in the display field for the physical exam of the abdomen. Now if we hit execute, we see that the question column with its associated headers is displayed for the user to choose any of the options that the developer wants to offer at this point in the exam. Now let's examine how data can be tagged with an unlimited number of data elements. The design of these templates is based on the premise that text fundamentally contains all of the information in the medical record. To see some, but not all of the data that might be associated with choosing a particular question, let's double-click on local guarding. From this list, you can see that a host of behaviors and data tags can be associated with choosing local guarding. For example, there is the question, the text return, the field assignment, where the text should be displayed in the record, the ICD-9, which is really shorthand for diagnosis codes, which contain ICD-9, ICD-10, SNOMED codes, as well as an independent ranking acuity model. And in this case, codes associated with what we have historically called the HCFA list. When we double-click on the HCFA list, we can see that there are a series of codes associated with evaluation and management. Number 47 refers to GI and abdomen. If we scroll down to see what number 226 is, we can see that there are a huge number of things that can be associated with these various tags. By the time we finally get down to 226, we see that this is making reference to palpation for masses or tenderness. This list is obviously much more flexible, and as you can see, when we scroll down, text can be tagged with a virtually unlimited number of identifying data tags. If we return to the list of possible tags associated with a choice, you can see that there are a huge number of possibilities, ranging from the behavior of the choice. Is it a title? Should the user be forced to make a choice? Can this be asked only once? Should this choice generate an output? Should the display be limited to a particular user type, for example, a physician or nurse? Choices also may have associated follow-up questions, i.e. be linked to another template that will display when that particular choice is made, along with a literal cornucopia of additional options, such as procedure codes, CPT codes, diagnosis codes, a number of open-ended tagging systems, which literally have thousands of defined data capture points, including the HCFA list, which is physician-centric, and the JCO list, which is nursing and workflow specific, plus the ability to enter drug and non-drug orders, HCPCS codes, and literally an unlimited number of other existing and new tags as needed. Finally, let's look at the content of an instruction by examining the XML. This is where the strength of the medical editor becomes evident. The user simply needs to know what tags and behavior they want, But in the background, all of this is automatically translated into XML. The developer may not even know what XML is, but when we review the XML content of this instruction, we see that all of the elements are neatly displayed. This XML document is all that is needed to generate the user display for this single instruction and capture the text return and all of the rest of the data associated with this one choice. With more than 10,000 templates, which can have from 1 to more than 1,000 choices, and each choice can have an unlimited number of data tags, and each of these templates can be linked to any other template, you can appreciate that our existing knowledge base has many hundreds of thousands of choices and literally many millions of data elements. This flexibility and data-rich structure, to our knowledge, is both the most flexible and the most robust of any electronic health record available. But the most important design element is that this content is meant to be developed by the clinicians themselves. This leads us to a summary of the basic design of all templates. First, the assumption is that all text can be tagged with an unlimited number of codes and values. It can be linked to any other template to generate a cascading list of choices, as well as restricted by user, by sex, by age, indeed by any criteria that the user could imagine. Second, storing all of this information in XML not only eliminates innumerable complex data tables, it also offers unlimited and literally on-the-fly flexibility. New tags can be added as simply as defining a new XML tag. And finally, the clinical developer can simply decide what and how they want to display various choices and can add as many metadata tags as needed without knowing anything about XML or relational databases. In the next series of slides, we will show you how easy it is to add new content and modify existing content. Now let's take this simple template and add a new instruction to demonstrate how easily sophisticated content can be generated by clinical experts. We return to our old friend add RLQ exam choices, which has already been loaded and has been checked out so that modifications can be made. In our simple example, we're going to copy an instruction associated with local guarding and then make modifications to that existing instruction. We could just as easily have inserted a new instruction and started from scratch, entering the question, the text return, etc. But in the interest of simplicity, we'll just copy and modify an existing instruction. Let us assume that the center we're working at has in-house ultrasound capabilities. We might want to allow the user to further describe the amount of guarding and then offer them the option to order a in-house ultrasound. This can be accomplished very easily. First, we choose to copy the instruction, then we're going to paste the instruction, and then we're going to check it out. And we can modify the question to read local guarding, and then we're going to say order an ultrasound. We can then allow the user to further describe the guarding by asking them to enter a free text description. We can do this by choosing a fill-in-the-blank follow-up question. And finally, we're going to add a follow-up question. The follow-up question that we want to add is related to the ultrasound general worksheet graphic. And so we've already looked that up. And we're going to look in here. And this is the follow-up question that we want. And so we go back and everything is okay. But before we check our new changes out, let's make sure that there's no pre-existing data by looking at the current output. So this is the output that's been generated, so there's no output. Now let's execute our new medical problem and see what changes we've made. So we're going to go ahead and execute it. And you can see that local guarding, order an ultrasound, is now a new choice. This follow-up question asks us to describe with further text which then brings us to the ultrasound general worksheet graphic. We can document an ultrasound. We're going to do a complete ultrasound of all quadrants. And this asks us for the indication. It asks us for what we think is going on. And it takes us to a general purpose abdominal ultrasound worksheet. We can talk about the liver, the gallbladder, or we can just make a comment. We can sign in as the sonographer. We can document the date that the exam was done. And then we can save this as a part of the chart. When we return back, we can see that we've actually already placed an order for an ultrasound. This is the ultrasound. You can see that the indication is abdominal pain and the comment is possible appendicitis. So, in the process of making just several changes, we've generated a huge amount of data. Now let's look at the amount of data that we've actually generated. Remember when we first looked, there was no information. And now, if we look at this, there is a huge amount of XML that's generated. Each one of these outputs is associated with a particular question and a particular output. This, for example, is the order that was placed. The order was, this is the order ID, this is the name of the order, this is the type of the order, this is the comment, this is the indication. You can go down here and we can see that the code that's associated with is ICD-10 of R10.84, abdominal pain is suspected, and on and on and on. And so, with this simple example, we've demonstrated the power and sophistication that can be placed into the hands of clinical developers. If this tool is appropriately marketed and distributed to clinical developers, and the existing infrastructure is enlarged to support hundreds, if not thousands of clinical developers, it is in fact inherently designed to support this type of load and this type of expansion. We believe this solution will become the de facto development environment for all clinical electronic health records.